Okay, so let's write a web server that serves a static HTML website. So let's say when we access our server on port 3000, it should serve either the index.html file as the default route or allow the user to access a specific file as and when requested. Begin by downloading the web server begin archive file from the download section and extract its contents into a folder where we'll write our web server script. This folder contains a sample HTML website that we'll use in this project. Diving a bit deeper, this is how our web server would work. So let's say you're asked to serve an index.html file lying in the current folder. The first thing your code needs to do is to check if this file is available or not. It is possible that a particular file that you wish to serve is unavailable. In that case, we'll throw an error, most likely a 404, which means content was not found on the server. But if the file is present, then we may want to try and read it into memory. If this works, then we'll simply send it back over the response, and if not, we'll throw an error. Since all these are asynchronous operations, we'll have to use the callback interfaces to chain these sequential methods together. So let's jump into code now. I've already extracted the contents of the web server begin archive into a folder on my drive, and as you can see, it contains a bunch of HTML files along with the style sheet, images, and some JavaScript files as well, all organized into folders. When the user accesses the default route, that is when request.url returns a simple /, as you saw in the router example, we want to serve the index.html file here. When the server serves this file, the browser will request its assets such as images, style sheet, etc. to be loaded as well. We want to intercept all these requests and serve the files accordingly. So let's first create a new file, and I'm going to save this as webserver.js in the root of the web server begin folder. As always, I'll begin by typing out the use strict expression on the very first line of my script file. Now, the first few lines of our web server will seem very familiar by now. We are creating a function called web server, which will be invoked as the callback from our HTTP server instance running on port 3000. Our very first task now is to resolve the path to the requested file. If the requested route is the root route, that is 1/, then this means our web server should serve the index.html file by default. Otherwise, the requested route should be served since it would point to a specific file. This file could be anything, an HTML file, a CSS file, JPEG or PNG images, or even a JavaScript file. So first, let's use the URL module to extract the path name from the request.url object. Remember, we need the exact route, and though the request.url will provide that on its own, it will not resolve correctly if the user includes URL query parameters, for instance. So in all situations, we have to resolve the route. And the best way is to parse the request.url data using the url.parse method. Let me bring in the URL module as well. By the way, we have been using these modules for a while, and you may be wondering how they work. Don't worry, a deep dive into modules is coming up soon after we are done with the web server examples. For now, just have fun with the ones we are importing in using the require statement. Okay, now we know that base URI.pathname will provide us with the exact route. We did the same thing in the router example as well. So now, using the standard JavaScript ternary operator, we will first check to see if the route being requested, that is base URI.pathname, is equal to a / or not. If this is the case, then we mean to serve / index.html file. And if not, then it means that the base URI.pathname points to the exact path of the file that we want to respond with. Let's console log this out to see what we get. So if we try and access just the localhost :3000 address, then you can see our file path variable resolves to /index.htm. However, if we are referring to an exact path such as this CSS file, then we are going to get that directly as our file path. And this sort of a thing will happen when we load our HTML pages, since they will request their assets such as this CSS file. To resolve the exact path on disk to these files, we'll prefix in the absolute path to the folder where our webserver.js file is being executed from. Node makes this really easy by providing us with the built-in _dir name property. Let's hold on for a moment and learn more about this. To get the current working directory, Node actually provides us with two methods: the _dir name property and the process.cwd method. CWD here stands for current working directory. Both these seem to do the same thing, but they work a bit differently. Let me illustrate that with a small example. So let's say we have a folder sitting in the root of your hard drive called my NodeJS app. In this folder, we've got server.js, which is a simple Node.js script, and we have another Node.js script sitting in a folder called my module. So imagine the my module is some module that we are going to import in to the server.js from where it will be called. This would be like the various modules and methods you've seen so far. So on top you see server.js, which first imports the my module file, and this should give you a first glimpse of how a custom written module can be imported in. But more on that in another screencast. Anyway, coming back to this example, the mymodule.js file, which sits in its own folder, simply provides us with a function which outputs the values of both _dir name and the process.cwd method. We are calling this function from within server.js, and we are also outputting _dir name and process.cwd values as seen by the server.js as well. So in a nutshell, we'll get to see what this will resolve to in the server.js and in the mymodule.js when it is called from within the server.js script. So _dir name, when called from the server.js file, resolves to the folder my NodeJS app. This is the folder which contains the server.js file. The _dir name in the mymodule.js resolves to its local folder, that is my NodeJS app /mymodule. What this essentially means is that the _dir name property is local to every module that you import. Your main entry point, that is server.js in this case, resolves this differently from your modules, and hence you need to use it appropriately. If you have a file in the root of your app folder structure and some module sitting deep in a folder has to read it, then the _dir name property may not work directly, since it will resolve to the module's own folder. On the contrary, the process.cwd method returns the current working directory of the calling process. So if we are running server.js by using the node server.js command on the terminal, then server.js becomes the calling process, and its folder is then universal for all modules and the entire app. So no matter how deep your module sits in its folder, the process.cwd will still return the directory where your calling process, that is server.js in this example, resides. Back in our web server example, I'll use the double_dir name property since my webserver.js sits in the root where my index.html and other HTML files reside. And the double_dir name property gives me the path to these files easily. Let's see what we get in the file path variable after making this change. Restart the app, and now if we try to access a CSS file sitting in a folder called CSS, the complete file path resolves to something like this. The resolution here is from the root on my hard drive all the way to the file at the end. You can try this for the root path and it resolves to the index.html exactly how we expected it to work. Alright, now we need to read and play with the files from within our node environment. The first thing to do is to find out if the requested file as per the file path variable is accessible or not. Because if it is not accessible, it probably means it's not there and we won't be able to serve it. For all file-based I/O, Node provides us with the file system module or FS. So as always, we'll create a constant to bring the FS module in like so. The methods within the FS module lets us do a ton of things like reading and writing files, renaming files, changing file permissions, watching files for changes, and lots more. This should also give you a sense of what Node brings to the JavaScript world, since these things are not possible when V8 works in the Chrome browser. But in Node, V8 interfaces with libuv to access and interact with hardware such as your hard drive and its contents. So, to check if the requested file is accessible or not, we'll use the fs.access method. The first argument in fs.access is the file path. So we'll just key in the file path variable, which has already been resolved by now. Next, we'll type in the fs.uppercase f_ok. This denotes one of the modes that the fs.access is going to test your file on. The fs.f_ok basically checks to see if the file is available or not. This is also the default option, which means even if I do not specify this option, this is what the fs.access method will test your file on. But we've got other modes here as well. While f_ok does tell us if the file is accessible or not, it doesn't really say anything about the read, write, and execute permissions on the file. For those, we've got the r_ok, w_ok, and x_ok modes. So for our purposes, f_ok works fine, and we'll create a callback which provides us with an error property should there be one to act upon as needed. Note you can also use a bitwise OR operator to club two permission checks. So for instance, doing something like this would make the fs.access method check for file accessibility or if the file could be read in. Now inside the callback here, we will check to see if the error variable returns an error or not. It would return a null if the file is accessible. So if there isn't any error, we'll read and serve the file. If however there is an error, then it means the file is not there, and for simple purposes, we'll throw an error status code 404, which means content not found. Alright, time to read the file in. For this purpose, we'll use a method called readFile, which essentially reads a file from disk and buffers it into memory. So clearly this will not be very efficient. But don't worry, we'll fix that soon enough. For now, we'll stick to the readFile method for this example. The first argument here will be the file path variable, and the callback function here provides us with two arguments, an error and the access to the content from the buffer. You'll notice that error is the first argument in the callback, and this is pretty much a standard practice across most callback functions in Node.js. Do keep this in mind. So Like the fs.access method, here too we'll check to see if there is an error or not. If the file is accessible and still there was an error reading it, then in this case we'll probably throw a 500 server error with the message the server could not read the file requested. If on the other hand, the file was successfully read in, we'll first have to resolve the MIME type of the content we are about to serve. In the past, we have served mainly HTML strings, and those were done using the text/HTML MIME type. However, now we would need to serve HTML files, images, style sheets, and JavaScript files. So we cannot keep using the text/HTML MIME type for all such responses. Therefore, we'll have to dynamically resolve a content type for every request. For this purpose, let's create a small collection of known MIME types, and this by no means is comprehensive. I'll create an object called MIMEs where I'll make key value pairs mapping file extensions to their corresponding MIME types. So .htm files will use the text/HTML MIME type, while .css would use text/CSS, and so on. Again, note that this is not a comprehensive collection of MIME types. However, this works for our purpose for now. Now, for every file path in the file path variable, we'll have to extract the file extension. You can do this in several ways, such as using the standard slice method in JavaScript like so. This will extract the last 4 characters including the dot from the file path string. However, this situation gives me the opportunity to show yet another helper method from a built-in module that comes with Node. So let's first create a variable called content type, and we'll access the MIMEs object using the array notation, which allows me to type in the key in the brackets as you saw earlier in the router example. Now the module I was talking about is called path. So first, bring that in like so. Next, to extract the file extension from the file path directly as the key, we'll access the extname method from the path module and we'll supply it with the file path variable like so. This will then resolve the correct MIME type based on the reference to the file extension in the file path variable. So for instance, if it's a CSS file, then first path.extname will extract .css and the entire expression will compute down to text/CSS. Simple, right? So at the end, once we have everything, we'll use our familiar res.writehead to serve status code 200 followed by the content type header, whose value will be set to the value as extracted into the content type variable. Finally, follow it up with the res.end, where we'll first dispatch the content as provided to us by the read file method, and we are also going to set the encoding type to UTF-8. The encoding type parameter is optional, and we are setting this to UTF-8 since most HTML pages are encoded using this format. Alright, time to run our little web server. And if we now access the root URL, you can see that it serves our sample website just fine. You can also browse around and you can see specific route requests are being mapped and served correctly. We'll just do one more thing here. I'm going to add a console.log statement which prints out the file path variable. This is to get a visual idea on what routes are being served at the moment. And there you go. Now let me size down the font, and I want to talk about an important point here. As you can see in this example, we first made a function within which we used the fs.access method, inside of which we used the fs.readFile method. So we've got callback inside a callback inside a callback. This is most commonly referred to as callback hell in the Node.js world. And though it easily gives you a complete picture of your app, it also poses a huge challenge for us as far as code management and organization is concerned. So in the next screencast, I'll refactor this code and we'll try and resolve the callback hell problem.